다음 발표는 마찬가지로 민병훈 교수님 교신으로 박은지 강사 선생님이 준비했습니다. 준비되면 발표 부탁드리고 있습니다.
네, 제일 처음에. 네. Good morning, dear professors and colleagues. This is Unji Park, a clinical fellow from Division of Colorectal Surgery. For today's research seminar, I'll introduce my recent animal experiment using porcine model for assessing safe grip forces of robotic surgical instruments. This was supervised by Professor Bang Soo Min. These are the contents I'll follow. As you know, in robotic surgery, one of the well-known drawbacks is the lack of tactile sense when handling various tissues within the surgical field. However, as expertise builds up, this limitation can be overcome by visual accommodation. But for novice surgeons who have yet to overcome the learning curve, can unintentionally damage patients' tissues without even realizing, which can lead to detrimental results. So, since robotic instruments' grip forces are a master and slave system in which a set output is projected when activated by an adequate grip motion, it is important to set the parameter for safe forces via certain types of experiments. Experiments of such purpose have been conducted over the last few decades, although they were infrequent. They were all for different instruments with different systems. And because we wanted to conduct an in vivo animal model experiment, but as I had personally little experience in this area, I searched for some reference to learn and benchmark, especially about the methodology. So this is an article by a group of Japanese surgeons in which they aim to find the optimal safe grip forces of laparoscopic forceps in small bowels of dogs. They used this setup as seen in these photos. If you put an input of a certain magnitude of force into the actuator over here, it will deliver the force into the tip of the instrument connected, and they would project the certain amount of force. They chose 5 to 80 newtons of force of grip motion to grip the small bowels of dogs at 2 centimeter intervals. And for results, they examined macroscopic and microscopic tissue damage. And for macroscopic inspection, they looked for serous defect, hemorrhage, hematoma, and grip marks. And for microscopic tissue damage, they reviewed histologically of in what depth the damage had occurred. So after checking for all samples, the maximum grip force that produced 0% of incidence of hemorrhage or hematoma was 15 newtons. And also 0 microscopic injury to the external longitudinal muscle was found below 15 newtons of grip force as well. So they concluded that 15 newtons of pure grip force applied to the small bowel of beagle dogs was safe in terms of microscopic and macroscopic damage. Another example of a similar study design was this article shown here by a group of Canadian surgeons as well. And this study investigated tissue trauma caused by compressive stress created by a standard laparoscopic instruments using a new device they developed. So as you can see here, this is the device they developed. It's called Simple Cat. It would project a certain amount of compressive pressure onto a piece of tissue set on the bottom here. And they used human colon tissues to test. And the pressure they applied was 150 to 650 kilopascals, which were equivalent to 3 to 12.8 newtons of forces. And these were chosen because they were the force range of what standard laparoscopic instruments would perform. And they also did histologic reviews for tissue trauma scoring by a pathologist. In their conclusion, they found that the tissue damage was The tissue damage correlated to the gradual increase in compressive force. But significant tissue damage occurred at 450 kilopascals, which was which was equal to 8.9 newtons of force. So bearing in mind in those designs, we designed our experiments as shown in this flow chart. The experiment was divided into two steps mainly, and we chose a certain range of grip forces to test on a certain instrument, and applying that grip force on small bowel and colon of pig, we would do a macroscopic examination immediately after the grip forces were applied, and the pig was raised for 1 week, and then we did a gross examination again, and also histologic review at the end. So this is to show the machine that we use to measure the grip force. If you grip the ends of the detector jaws over here, it would deliver the grip force to the sensor in the middle, and the grip force received at the end would be converted to a unit we can assess on the monitor. This is a photograph of us actually using the instrument during the experiment. The instruments we chose to test were two instruments. First was atraumatic fenestrative forceps, which was the most used instrument to handle the small bowel or colon during the operations. And another one, it was needle holder, which was not intended to handle or grab any tissues intentionally, but for some cases while doing your sutures, you have to inevitably hold some bowels to aid in needle motion. So we chose these two instruments to test. And for macroscopic examination, we looked for serosal defect, hemorrhage, hematoma, and grip mark as well. Below are the examples of gross examination findings. Here's some hematoma and grip mark found. And for histologic review, we asked for a pathologist who was blinded to the experiment concept and looked for tissue trauma on these samples. And this is an example of a grade 1 tissue damage shown as indicated by these black arrows. And some tissues showed submucosal edemas, as you can see on the right side photo. And we shown you some footages of our actual experiment conducted. And after placing ports for camera and instrumental cannulas and docking of the RevoEye robot system, we selected the small bowel and colon for grip and marked the anatomical directions with sutures at either ends, and applied grip motion at about 2 to 3 centimeter intervals, which was marked previously. And I made sure that bowels being tested was not directly handled, so I would retract the bowels by holding the threads instead of grabbing the bowel itself. So this is a scene where I would grip the small bowel with atraumatic forceps, like so, and colon tissue with atraumatic forceps. And the same procedures were done for needle holders on small bowels. And each grip was for 30-second intervals. And lastly, for colon tissue, using needle holders. And after the gripping was done for all the forces intended, we would make sure to visualize all the bowels and carefully examined all the surface areas for macroscopic damage and recorded them for later reference. So, since we wanted to compare the exact safe grip force we would apply on the bowels, we calibrated the force that was used for these instruments, and the force we would apply to atraumatic forces was chosen in the range of 4 to 12 newtons. And for needle holders, it was 5 to 25 newtons in the intervals of 5 newtons. And you can see that from these tables that that all the results ended in within the accepted range of error. So these graphs show that show the macroscopic examination results from the small bowel and colon using the two instruments we tested immediately after the gripping. And as you can see, there were no serosal defect or hemorrhage shown in these samples. And some grip marks showed on 8 newtons or higher force on small bowel using atraumatic forceps and at 12 newtons on colon. And grip mark was shown in 20 newtons in colon held by needle holder, and some hematomas developed after 20 newtons or higher force in small bowel or 25 newtons in colon tissue. And after 1 week of raising the pig, during which time there was no complication with the animal, we conducted the second experiment in which we harvested the bowels and looked for macroscopic damage or any delayed macroscopic damage, if any. And these are the results after 1 week. And as you can see, the any grit mark or hematomas developed in the small bowel or colon using atraumatic forceps had been disappeared on the samples after 1 week. And on small bowel, some hematomas remained on the 25 Newton spot in small bowel and colon. And interesting, and a newly developed hematoma on the 15 Newton spot was observed in the small bowel using needle holder. And as I said before, the pathologic review was done and there was no significant grade 2 or 3 damage noted in all of the samples. However, some serosal fibrosis and subserosal edemas were found in colon tissues in these samples. There were no definite mucosal lesions in all groups. And these are the results of histologic review. As you can see, there were no serious grade 2 or higher trauma to the tissues, and some grade 1 or submucosal edemas could be found in the colon tissues handled by either of the instruments. And additionally, we conducted another experiment on a separate pig. We wanted to make sure that the force that we were using on the Robotic system for atraumatic forceps and needle holders was safe to hold for some time. We differentiated different gradual grip time forces and looked for macroscopic or microscopic damages on these tissues. So these are the gross photographs of the samples we conducted this supplemental experiment where we can see the grip marks for 30 seconds to 5 minutes of hold time at the default grip force that we were using on the actual Robotic system. And these graphs show the macroscopic damage done to these samples. And similarly, there were no serosal defect or hemorrhage on these tissues. Some grip marks were shown on small bowel and colon after gripping the bowel for 1 minute for small bowel and 3 minutes for colon. And some hematomas were also shown for small bowel who was gripped for 3 minutes or longer, and for 5 minutes or longer for colon. And for needle holders, some hematomas developed after 3 minutes in the small bowel and 5 minutes in the colon. And some grip marks was also shown in 3 minute time at small bowel and colon as well. So, and histologic review of these samples also showed similar results where there were no grade 2 or higher tissue trauma, and there was only a grade 1 and submucosal edemas found in the colon tissues. So to summarize the our study, we can say that the range of grip forces between 4 to 12 newtons for atraumatic forceps and 5 to 25 newtons for needle holders can be considered safe when gripping small bowel or colon. This is similar to previously reported results that showed that 15 newtons or less force is considered tolerable. And the additional experiment with different grip times as current system's default force show that it is safe to grip bowels for a brief amount of time. And also for human tissues, we should keep in mind that human tissues, and especially patients with different pathologic conditions, have different conditions in which can result in different effects from same force applied. And this study only tested for the grip motion, which is limited to explain the real world application where tissue handling also includes pulling, pushing, pinching, or stroking, etc., and other types of forces. These types of studies tend to have conclusions that are very specific and pinpointed, like our study, and they can later be used in the development of such technology like haptic feedback system, which is being developed in the robotic system. These are the references I used, and thank you for your attention.
박은희 선생님 감사합니다. 발표 아주 잘해주셨고요. 일단 오늘 발표하신 두 강사 선생님에 대한 피드백 전체 채팅창에 있으니까 나가기 전에 클릭해 주시고요. 발표에 대한 질문이나 코멘트 있으시면 잘 부탁드리겠습니다. 시간이 많지 않아서 아마 한두 분 정도 부탁을 드릴 것 같습니다.
간담체육과 김상현입니다. 들리시나요?
네, 교수님 들립니다.
네, 발표 잘 들었습니다. 제가 궁금한 거는 이게
네.
압력의 정의가 이제 단위 면적당 가해지는 힘인데 이게
네.
이거를 그래스퍼로 이제 누르는 힘이 결국은 바울을 조금 이렇게 끝허리만 살짝 잡는 거랑 좀 벌크하게 넓게 잡는 거랑 이런 거에 따라서도 차이가 있었는지 그런 게 일단 궁금하고요. 그리고 이게 이게 수치화해야 되기 때문에 사실 뉴턴이랑 단위를 써야 되는 걸 맞긴 한데 이게 임상 프랙티컬에서는 요 정도 힘이라는 게 이제 어느 정도의 느낌인지 사실 감이 안 잡혀서 그런 것들이 이제 어느 정도인 건지 조금 개략적으로라도 조금 알았으면 좋겠고, 그 다음에 하나는 이제 어시스턴트 트랙션을 시킬 때 가끔 바울을 이제 잡으라고 하긴 하는데 가급적이면 스페시맨 쪽을 잡으라고 하긴 하는데 어쩔 수 없이 남는 쪽을 잡아야 되는 상황이 있는데 가끔 가다 보면 이제 오래 잡고 있으면 힘드니까 선생님들이 이제 그 라파스코피 디바이스를 락킹을 하고 그냥 들고 있는 경우가 있는데 이 정도 락킹 정도에 되는 힘은 여기에서 말하는 그런 트라우마를 줄 정도의 힘은 아닌지 그런 것들이 궁금합니다.
네, 교수님 질문 감사드립니다. 먼저 첫 번째 질문 주신 그 잡는 면적에 대한 차이를 이제 설명을 드리면, 사실 말씀하신 것처럼 이제 그 그라스퍼 조 전체로 티슈를 진짜 다 포함해서 잡는 경우와 이제 팁만 이용해서 살짝 이제 잡는 경우랑은 당연히 이제 가해지는 그 포스가 이제 그 면적에 따라서 다르게 되고, 또 그런 포스가 정말 풀로 가해지는 것과 이제 뒤에 있는 티슈와의 이제 가해지는 그 포스는 사실 차이가 있을 것이라고 생각을 하는데, 이 실험에서는 그 정말 저희가 로봇 수술을 할 때 이제 뭐 바울을 잡는 것처럼 실제 이제 도킹을 해서 콘솔에서 이제 그랩을 할 때 이제 최대한 바울을 풀 이제 thickness로 다 잡으려고 노력을 하기는 했고, 사실 그 잡는 면적의 차이를 고려해서 이제 전체적인 티슈에 똑같은 포스를 가하려면 아까 제가 레퍼런스에서 보여드린 그 두 번째 스터디처럼 정말 컴프레시브 포스로 그런 정해진 값을 이제 주어지는 방법밖에는 없어서 사실 이게 저희가 실생활에 이제 실제 이제 로봇 수술이나 이제 기구의 어떤 세팅 자체를 바꾸는데 이제 참고할 만한 자료가 되게끔 이제 하는 실험의 목적에 따라서 사실 그것보다는 이제 실제로 이제 이 정도 포스는 이제 그립 자체의 포스는 그 기계로 측정했을 때에서 칼리브레이션을 해놓고 그 정도 포스를 이제 가했다고 했을 때 나오는 그 트라우마를 보고자 한 것이고요. 그리고 두 번째 질문 주신 거, 두세 번째 질문 주신 것처럼 이제 그러면 이 제가 말한 이제 저희가 썼던 포셉에서 이제 4에서 12뉴턴 정도는 어떤 정도의 이제 힘인지 말씀을 드리면, 사실 이것도 정확히 제가 좀 발표를 하면서 좀 부연 설명을 드리면 좋을 것 같아서 레퍼런스를 정확히 찾아보긴 했지만 엄청 명료하게 이거를 정의한 바는 수술에서 이제 적용해서 정의한 바는 이제 없기는 했고 통상적으로 다른 레퍼런스에서 보면 저희가 라파로스코프를 하면서 이제 그 바울을 핸들링하고 어떤 그래스퍼를 이용해서 티슈 핸들링을 할 때 나오는 포스가 한 1에서 4뉴턴 정도의 힘이라고 하기 때문에 이제 저희가 사용했던 이제 force들은 사실 실사용보다는 훨씬 높은 force라고 보시면 돼서 정말 인텐션을 가지고 엄청 더 세게 잡거나 아니면 정말 오픈해서처럼 더 힘을 가할 수 있을 때 force를 좀 적용했다고 보시면 될 것 같고 그리고 이제 트랙션을 할 때 마찬가지로 이제 락킹을 했을 때 그러면 이게 어느 정도 force를 가지고 있는지에 대해서는 이 실험으로는 사실 설명드리긴 좀 한계가 있을 것 같아서 그런 부분을 좀 다른 추가적인 비슷한 디자인의 실험을 할 때 좀 적용을 해서 측정을 해보면 좀 저희에게 좀 이렇게 도움이 되는 자료가 될 수 있지 않을까 생각합니다.
김경식입니다. 지금
네, 교수님.
박은지 교수님 잘 말씀 주셨고요.
네,
그거를
교수님.
비주얼라이제이션 방법이 두 가지가 있는데요.
네,
하나가 우리가 영양 평가할 때 그래스핑 파워를 재거든요.
네, 네,
그래서 그런 기계들이 있어서 핸드 그립 하면서 할 수 있는 게 있고요. 또 하나는 지금은 이제 혈압계가, 수은 혈압계가 다 없어졌는데,
네,
제가, 일전에 샌딩 콜란자이티스 막으려고 프레셔 측정하는 거를 해봤었는데, 그때 수은 혈압계 갖고 한번 자기가 쥘 때 이렇게 혈압계 올라가는 게 눈으로 보이거든요. 그런
네.
식으로 했는데 지금은 수은 혈압계가 없어져서 좀 이렇게 눈으로 가시적으로 볼 수는 없겠지만 핸드 그립 하는 방법이 있으니까 같이 한번 비교해 보시면 좋을 것 같습니다.
네, 교수님, 감사합니다.
혹시 추가 질문이나 코멘트 아마 한 분 정도만 주시면 좋을 것 같고요. 없으시면 시간이 다 돼서 일단 김경식 주임 교수님께 저희 교실원들한테 말씀드릴 사항 부탁드리겠습니다.
예, 따로 말씀드릴 건 아니고요. 오늘 지금 윤동섭 차기 총장님께서 저희랑 함께 하고 계십니다. 그래서 윤동섭 우리 원장님, 총장님 혹시 마이크 들리시나요? 인사 한 말 가능할까요? 지금 들어와는 계신데 네네.
안녕하세요. 들리시나요?
네, 잘 들립니다.
예, 안녕하세요. 감사합니다. 어, 평생 몸담아왔던 외과 교실에서 모든 분들이 정말 열성적으로 이렇게 응원도 해주시고 지원도 해주셔서 이렇게 외과를 대표해서 학교에 일을 맡을 수 있는 그런 큰 기회를 가진 것 같습니다. 깊이 감사드리고 이렇게 지원해 주신 거에 잘 보답할 수 있도록 학교의 발전을, 대학의 발전을 위해서 최선을 다하겠습니다. 혼자 보내만 놓지 마시고 자주 찾아주시고 자주 이야기를 해주셔서 학교 일을 할 때 우리 교실원 여러분들의 여러 선생님들의 의견도 잘 듣고 해서 학교 발전에 잘 참고를 했으면 좋겠습니다. 하여튼 정말 뭐라고 감사하다는 말씀을 드려도 충분하지는 않을 것 같은데 하여튼 최선을 다해서 학교 발전을 위해서 노력하는 것이 우리 교실원들께 보답하는 길인 것 같습니다. 최선을 다하겠습니다. 진심으로 감사드립니다.
네,
이런
감사합니다.
기회를 주셔서 주임 교수님 감사합니다.
자, 임경 교수님.
네, 총장님 감사합니다. 주임 교수님께도 감사드리고, 네, 이 자리가 또 많은 분들 참석해 주셨는데 또 이렇게 또 훈훈한 감사 인사와 또 당부 주셔서 감사합니다. 이것으로 10월 30일 외과 교실 리서치 세미나는 마무리하도록 하겠습니다. 감사합니다.
감사합니다.
감사합니다.